These are the Chapter 6, Notes 11 on tree diagrams and conditional probability. We're going to answer conditional probability questions today using tree diagrams. So here's our first example. Given 1,000 professional football players, 50% of them have taken steroids. Our test is 90% accurate. 90% of the time, the test gives a positive result for steroid users, and 90% of the time, the test gives a negative result for non-steroid users. If Big Bubba tests positive, what's the probability he has taken steroids? So we have a couple things going on here. We have whether or not the football player is actually taking steroids, and then we have whether or not the test result is positive or negative. So sometimes you might take a test and it might give you a true result. So if you're taking steroids, we would expect the test to be positive. But sometimes we get false results. Sometimes a steroid user might actually end up testing negative because the test didn't work out properly. Or vice versa, maybe a player isn't on steroids, but the test says that they are. So that could be a problem as well. And that's kind of introduced in this introduction here. So let's get after, first of all, whether or not the person is a steroid user. And it says, based on our study here, 50% of the 1,000 professional football players have taken steroids. So this 50% is going here under steroid users. And since these are complementary events, we can assume that 50% are obviously not steroid users. Our test is 90% accurate. 90% of the time, the test gives a positive result for steroid users. So if you are a positive user, 90% of the time, the test will say the results are positive. Of course, that's going to mean that 10% of the time, if you're a user, the test is going to give you a negative result. So if you're a steroid user, you're probably hoping the test result is negative. On the other hand, 90% of the time, the test gives a negative result for non-steroid users. So we would expect somebody not on steroids that the test should come back negative, as no, they're not taking steroids. That's kind of what you want. If you're not on steroids, the hope would be that the test agrees with that. On the other hand, worst case scenario would be players not taking steroids and the test says they are, and that should happen 10% of the time. So you can see 10% of the time the test does not match what actually happened. If you're a user, 10% of the time it says you're not. If you're not a user, 10% of the time it says you are. These values that are kind of in the second set of branches right here are considered to be conditional probabilities. So if we kind of look at this region right here, kind of in this region right in the middle, these values are conditional probabilities. If you are a user and you get a positive test result. So it's basically, if you're following this top branch, what's given is you're a steroid user. If it follows this bottom branch, you're not. So these values here you could kind of think about as being conditional probabilities. Now, what we're looking for here is a probability that if Big Bubba tests positive, what's the probability he's taken steroids? Well, there's two different ways that he could test positive. One would be if he's actually on steroids and tests positive, but the other is if he's not on steroids but still gets a positive test result. So what we're going to calculate over here on the right side are what are called joint probabilities. And what we're actually going to do on the right side here is we're going to do some multiplication, and I'm going to show the work here. If you follow this branch and then you follow the top branch, we're going to multiply these two probabilities together, and what you get is 0.45. This is the probability that both a person is on steroids and gets a positive test result. So this value we calculated is actually the probability of testing positive and being on steroids. So I'm going to say test positive and steroids. It's basically positive as well. Now you can calculate the other probabilities the same way, and it's important that you show this work. It's a step a lot of kids leave out. But if you multiply 0.5 times 0.1, you're going to get 0.05. That's the probability that somebody is taking steroids and gets a negative test result. You could also figure out these other probabilities. We're going to get the same results here. 0.5 times 0.10 is 0.05, and 0.50 times 0.90 is 0.45 again. And just to be clear, what we've calculated here with this branch going downward and then this branch coming upward is the probability that somebody tests positive and is not on steroids. So let's go back and answer this question. If Big Bubba tests positive, what's the probability he's taken steroids? So we're looking for the probability that he's taken steroids if, or given, he tests positive. So because it's a conditional probability, this answer is not going to be out of 100%. It's going to be out of just the ways that he could have tested positive. And there's two ways that he could have tested positive. Either he's up here, he's on steroids and tests positive, so he's in this group, or he's not on steroids, but he still tested positive. And these two probabilities add up to 50%. Out of these two groups, who in these two groups actually is on steroids? So out of just these two groups, not out of all four, but out of just these two circled groups, who in these two groups is actually taking steroids? This top group, 0.45 out of this 50. And when you divide this out, 45 divided by 50 is equal to 90. And that is the percent of people that meet this criteria. If Big Bubba tests positive, the probability he's actually taken steroids is 90%. Let's look at a second example. And in this example, it says, suppose we assume that 5% of people are drug users. Test is 95% accurate, which means if a person is a user, the test result is positive 95% of the time. And if he or she isn't a user, the test result is negative 95% of the time. Randomly chosen person tests positive. What's the probability that the individual is actually a drug user? So kind of like last time, we have this pre-existing condition, whether or not the person is, in this case, a drug user. So we're going to start off with two branches here. One represents people that are drug users, and one represents that people that are not. So I'm going to say users, yes or no. And it says assume 5% of people are drug users. So if we assume 5% of people are drug users, that means who's not? The other 95%. These percentages should always add up to 100. Now, if you are a drug user, we have this drug test. And if you aren't a user, you're still going to be taking this drug test. And the test result is going to come back as either yes, you're on drugs, or no, you're not. And the test is fairly accurate, but it's not always going to be accurate. And it says if a person is a user, so again, here's this if statement, the conditional probability. If they are a user, so we follow this top branch, the test result is positive 95% of the time. So if you are a user, 95% of the time it will say you are, which means 5% of the time it will say you aren't. So a drug user would hope that the test would say negative. On the other hand, if you're not using drugs, the test result is negative 95% of the time. So if you aren't using drugs, we would hope that the test would say, yes, you're not taking drugs. On the other hand, if you're not taking drugs, the other 5% of the time, the test will say that you are. So what we're going to do again is we're going to calculate the outcomes of all kind of four of these events. People that are using drugs and test positive, so and means multiply. We're going to multiply these two probabilities together, 0.05 times 0.95. And if we calculate that out, that gives us 0.0475. So there's a small percent of people that are overall users and test positive. An even smaller percent of people that are users and test negative, we're going to multiply 0.05 times 0.05, and you get a very small value here. And that's probably a good thing. If we're using drugs, we don't want to have a lot of people that are testing negative. That's 0.0025. Drug users, non-drug users, and people that test positive, these are the same numbers we crunched out up here, so this is also going to give us 4.75%. These are people that are going to be unjustly accused. And then we have the biggest set of the population, which are non-drug users that test negative. So we would expect most people to be kind of in this region. That's going to be 0.95 times 0.95, which equals 0.9025. So let's go about answering this question. A randomly chosen person tests positive. What is the probability that the individual is actually a drug user? Now, it doesn't say given, but this is kind of what we're choosing from. Out of the randomly chosen people that test positive. Well, who are testing positive? These people up here that are on drugs and tested positive, and these unfortunate people that that actually are non-users but still tested positive. Out of these people, what's the probability that this individual is actually a drug user? So out of these two numbers, we're going to take the people that tested positive, which are these people and these people, 0.0475 in both groups. And out of these two groups, who's actually a drug user? These people up here, the 0.0475 at the top. So out of the people who test positive, this is kind of another conditional probability. Out of the two groups that test positive, the people that are actually drug users are these people. And if you actually take 0.0475 and divide it by the sum of 0.0475 plus 0.0475, you get a surprising result, and this might be a little bit worrisome, especially for those people that aren't actually on drugs. You get 0.5. 50% of the time, if a person tests positive, they're actually a drug user. Which kind of means that 50% of the time, if you test positive, you aren't. So that might be a little bit worrisome, and that's kind of what happens with an example like this.